So hello again. This is a video about examples of computing phi of n with this faster method where you have the three steps or three statements which are still listed. So first example, n is equal to 61. So actually, if you do a little search or try a calculation, you will find that 61 is a prime number. So actually, knowing the prime numbers between 0 and 100 might be a good idea. So statement number 1 directly applies. Then phi of 61 is 61 minus 1 is equal to 60. So we have the value. Second example, n is equal to 81. So 81 is not a prime number, but it's equal to 3 times 27 is equal to 3 times 3 times 3 times 3 is 3 to the power of 4. So here, 81 is a power of a prime number, so we'll have to use statement number 2, so that actually it's actually some p prime number to the power of k, which is an integer number. And in this example, actually, p is equal to 3 and k is equal to 4, so that we can directly apply statement number 2. So I will write it here once again. Phi of p to the power of k, where p is a prime number, is equal to p minus 1 times p to the power of k minus 1. So here we just have to replace p by 3 and k by 4, so that phi of 3 to the power of 4 is 3 minus 1 times 3 to the power of 4 minus 1 is equal to 2 times 3 to the power of 3, which is 2 times 27, which is equal to 54. So phi of 81 is equal to 54. Next and last example. Not last example. We'll have another one after, sorry. N is equal to 91. 91 is not a prime number, and actually, if you try to make the calculation, 81 is 7 times 13. So actually, 7 and 13 are prime numbers, but what is of interest here is that the GCD of 7 and 13 is equal to 1. So we can use here statement number 3, meaning that phi of 91 is equal to phi of 7 times 13, and as the GCD of 7 and 13 is equal to 1, we are able to use this kind of decomposition process where we can write that phi of 7 times 13 is phi of 7 times phi of 13. Then phi of 7 is 6, as 7 is a prime number. Phi of 13 is 12, as 13 is a prime number, is equal to 72. So phi of 91 is equal to 72. Okay, I think that this should begin to make sense for you. Now the last example where n is equal to 200. Here, actually, we can see that 200 is not a prime number. It's not a power of a prime number. So actually, we'll have to do kind of same thing we've done for n equal to 91. That is, trying to write it as a product of numbers to be able to decompose it, and that's where one has to be careful because the decomposition is important because we want factors whose GCD is equal to 1. So, because this example is very classical and very often you can take a wrong way. So let's take the wrong way and show you why this doesn't work. And of course, I show you the right way just after. The wrong way is trying to decompose 200 without taking care of the GCD of the numbers we will get. Let's say, for example, 200 that's quite straightforward, is 20 times 10. Very easy. So, 1 really would like to write that. That's wrong because actually the GCD of 20 and 10 is equal to 10. So 20 and 10 are not coprime numbers. So you can't use this decomposition. So be very careful. If you try to decompose a number, you can do it only if the GCD of those numbers is equal to 1. So that's a wrong way to handle the thing. So what we have to do is to try several decomposition of n, which is equal to 200, until we find one which is suitable for using the third statement. So it's 2 times 100, and actually the GCD of 2 and 100 is 2. So that's not a decomposition. So let's go forward. It's 2 times 2 times 50 is 2 to the power of 2 times 50. Once again, the GCD of 2 to the power of 2, which is 4 and 50, is 2 because both of them are even numbers. So actually, we still cannot use the decomposition. So let's go forward. It's 2 to the power of 2 times 2 times 25, which is 2 to the power of 3 times 25. And 25 is 5 to the power of 2. So actually, that's not a kind of hazard. That we must end with a decomposition of the number of a product of power of prime numbers, which is a fundamental theorem of arithmetics. So from n equal to 2000 and trying decompositions, actually what we should get as a result is this kind of decomposition. So what we know is now 2 to the power of 3 is a number where the prime factor is only 2 or 4 or 8. On the other hand, 5 to the power of 2 is a number where when you have only 5 as factors. So here we can write that the GCD of 2 to the power of 3 and 5 to the power of 2 is equal to 1. Actually, it's 8 and 25. Okay? So as the GCD is equal to 1, then we are able to use the third statement. So phi of 2 to the power of 3 times 5 to the power of 2, as we know that the GCD of those numbers is 1, so that actually 8 and 25 are coprimes, we can write the following thing is equal to phi of 2 to the power of 3 times phi of 5 to the power of 2. And then we know that we can use this decomposition, okay? And that's where things become quite straightforward. Now that the decomposition is done, we know that we can use either statement number 1 or statement number 2. So actually, let's go deep in this example, okay, and make the complete illustration of what happens. Phi of 2 to the power of 3 is calculating using statement number 2 with P equal to 2 and K is equal to 3. So it's equal to P minus 1 times P to the power of K minus 1, which is 1 times 2 to the power of 2, which is 4. So phi of 2 to the power of 3, which is phi of 8, is equal to 4. On the other end, let's go for phi of 5 to the power of 2, which is also a power of a prime number, where p is equal to 5 and k is equal to 2. So this will lead, so I'll just write it under so that there is no confusion between the two blocks. The first one for phi of 2 to the power of 3. So it's p minus 1, where p is equal to 5, so it's 5 minus 1s, times p, which is 5, to the power of k minus 1, is equal to 4, times 5 to the power of 1 is 4 times 5 is equal to 20. So we've got here the values for both phi of 2 to the power of 3 and phi of 5 to the power of 2, so that we can write phi of 200 is phi of 8 times 25 is phi of 2 to the power of 3 times 5 to the power of 2. We know that, and this is very important, so be very careful at this decomposition step, is phi of 2 to the power of 3 times 5 of 5 to the power of 2, because 8 and 25 are coprime numbers, is 4 times 20 is equal to 80. So that's the way one has to handle numbers which are not prime numbers, which are not powers of prime numbers, so numbers for which you have to use a statement number 3 and be very careful about the decomposition of a number.